Okay, today's lesson deals with section 2.4, which is all about imaginary and complex numbers. First, we'll deal with imaginary numbers. When you take the square root of something, like say the square root of 25, that is 5. Simplifying the square root of 48, because there is no square root of 48, that's a whole number. Remember, you have to break this down, and things that multiply into 48 are 6 and 8, which then can be broken down to 2 and 3, and 2 and 4. The 4 can also be broken down to 2 and 2 if you want to. And then because it is square root, remember, anytime you have a pair of numbers underneath the square root symbol, they get together and they leave as just one of them. And so then there's also another square root of 2 and 2. Those two get together and they get to also leave as a 2. And then you would multiply these two things that are on the outside to get 4. And then the 3 is the only number left underneath, and so it's the square root of 3. Now another way you could have broken this number down to begin with would have been 16 times 3. And you could have stopped right at that point because you should know that the square root of 16 is 4. And then you're left with a 3 as well. Either way is fine as far as how you break it down. Eventually everyone should get to 4 square root of 3. Which then leads us into imaginary numbers. The square root of a negative 1 is I, an imaginary number. And so if we have the square root of a negative 25, it is very similar to this one, just because the square root of 25 is 5. The square root of a negative 25 means it's the square root of a negative 1 times the square root of 25. And so we know that this is equal to I, and the square root of 25 is equal to 5. So the square root of a negative 25i is, or the square root of a negative 25 is 5i. Then with something like the square root of a negative 48, again you can break it down. This would be a negative 1 times 3 times 16, and we know that the square root of 16 is 4, and then the square root of a negative 1 is I, and then the square root of 3. So it would be written that way. Now, lots of people will probably write 4i times the square root of 3, which is the same thing because you can multiply in any order. Each of these are different types of numbers. 4 is a real number that's rational. The square root of 3 is an irrational number. It is also real. And then I is the imaginary number. Either way that you write it is fine. You could even put the I at the beginning and then 4 square root of 3. That just looks weird, so don't do that, please. Now, moving on to other things with imaginary numbers. We know that I is equal to the square root of a negative 1, which then means that I squared is equal to negative 1. And then after that, I cubed, which would be the same thing as I times I squared, these two, that is going to equal I times I squared, which is, I is the square root of a negative 1, and I squared is a negative 1. And we know that this is I, and that's a negative 1, so we can say this is a negative I. Then after that, I to the 4th, which would be the same as I squared times I squared. And since I squared is a negative 1 times a negative 1 equals a positive 1. If we take this even further, I to the 5th would be the same as saying I times I to the 4th. And I to the 4th we know is 1 times I, so I to the 5th is the same as I. I to the 6th would be the same as I squared times I to the 4th. And so that would be a negative 1. I to the 7th would be I cubed times I to the 4th. And we know I cubed is a negative I, and I to the 4th is 1, which is also a negative I. And then our final one that we're going to look at would be I to the 8th, which is the same as I to the 4th times I to the 4th, which is 1 times 1, or 1. And now you will see that it follows a pattern. I to the first power is just I to the second is a negative 1, I to the third is a negative I to the fourth is 1. I to the fifth is also I to the sixth is a negative 1, I to the seventh is a negative I, and I to the eighth is 1. So anytime it is a multiple of 4, your answer is 1. Then the one before the multiple of 4 is a negative I, the one that is before that is a negative 1, and the one that is before that is I. So if you were giving something like I to the 43rd power, well, we know I to the 44th, which is a multiple of 4, is going to be 1. So then the one before that, I to the 43rd, is going to be a negative I. And so on and so forth. Now, all of those are imaginary numbers, and when you group that imaginary number with a complex or a real number, you end up getting a complex number. The standard form of a complex number looks like this: a plus bi. A is a real number. The plus bi is the imaginary number. Some examples of complex numbers would be things like 2 plus 3i. Or you could have 3/5 minus 7/5 I. Or something like that. Another complex number could be something like 27i, where there is no real number. This type is called a pure imaginary. And you can just have a plain old number, which is a real. And in this case, it's rational because it can be written as a fraction. Finally, because they're numbers, complex numbers or real numbers or whatever, you can perform all of the different operations of addition, subtraction, multiplication, and division. As you should recall, when you add, it's just adding like terms. 3 and 6, 2i and a negative 5i. So we would get 9 minus 3i. Subtraction is done the same way. 3 minus 6, which is a negative 3, and 2 minus a negative 5i, which is the same as 2 plus 5i, so plus 7i. Multiplying means you have to distribute. 3 times 6 is 18. 3 times a negative 5i is a negative 15i. 2i times 6 is 12i. And 2i times a negative 5i is a negative 10i squared. And then from the previous page, we know that I squared is a negative 1. So this becomes plus 10. And so our complex number would be 28 minus 3i. And finally, when you divide, first you should write it as a fraction. And then because you have an I in your denominator, you need to multiply by the conjugate, which is the first term of the denominator staying the same and the second term of the denominator going to its opposite. And then just going through and multiplying everything. So 3 times, in the numerator, 3 times 6 is 18. 3 times 5i is 15i. 2i times 6 is plus 12i. And 2i times 5i is plus 10i squared. In your denominator, 6 times 6 is 36. 6 times 5i is plus 30i. Negative 5i times 6 is a negative 30i. And a negative 5i and a positive 5i is a negative 25i squared. Simplifying all of this down, 10i squared becomes a minus 10, and a negative 25i squared becomes plus 25. And so you would have 18 minus 10, which is 8, plus 15 and 12i would make 27i. And in the denominator, 36 and 25 is 61. And a 30i and a negative 30i is 0. And so this would be your answer. Now, if you want to write it in complete complex number form, you should write 8 over 61 plus 27 over 61i. And that concludes this lesson on Chapter 2, Section 4.